Hello and welcome to Go Simulation. My name is Nick Leister, and in this video we're going to take a look at how SolidWorks Simulation can be used in order to analyze brittle materials. Now keep in mind, most of what SolidWorks Simulation is used for is analyzing ductile materials. So we have brittle materials and ductile materials. Now if you need a review or a refresher of what the difference is between a brittle material and a ductile material, I highly suggest that you go through Lessons 1 and Lessons 2 of Go Simulation. It's absolutely free. Just sign up, go through Lesson 1 and Lesson 2, and that will give you all that you'll need in order to be on board with what I'm going to do in this video. Now, keep in mind, like I said before, there's a difference between ductile materials and brittle materials. And we look at the failure of those materials differently. So with ductile materials, we might look at the failure in terms of the maximum von Mises stress or the shear stress criterion. Those are both ductile material failure criterions. And then for brittle materials, we have the Mohr Coulomb failure criterion as well as the max normal failure criterion. Now the max normal failure criterion does not treat tension differently than it does compression. Now that might be the case with some materials, but for our particular material, which is going to be granite, for our particular material there is a difference in the amount of tension that granite can take compared to the amount of compression that granite can take. As it turns out, you can compress granite way more than you can pull it in tension. So it's much more likely to break if you pull granite than if you compress granite. And because of that fact, what we're going to have to do is use the Mohr Coulomb stress criterion, because the Mohr Coulomb stress criterion treats tension differently than compression. Now, in this particular case, we're going to examine this bench. And this is a granite bench in which somebody is going to sit on this granite bench. Now, the granite is a very heavy material, and so what we're going to do in the simulation that we're going to create is we're going to simulate a 400-pound person sitting on top of this granite bench right here, and what we're also going to do is simulate the effects of the weight of the granite. Now, in order to create this simulation, what we're going to have to do is create a material, a granite material, and then what we're going to do is we're going to set up the simulation where we're going to, put a force of 400 pounds right here going down. Then we're also going to fix the legs, and then what we're going to do is we're going to run the analysis. And then after we run the analysis, I'll show you how to examine the failure of this bench in post-processing. Before we get started, what you're going to want to do is download the part that I'm working on right now. Now I've included both the completed simulation as well as a fresh part in the same state that you see it on my screen right now. So make sure to download both of those and have a look. Now what we're going to do is create the simulation that we're going to work on. So if you could come up to the Simulation tab on the Command Manager and click the caret below Study Advisor and then create a new study. And then under Type right here, make sure that the static option is pressed in, and then we're going to give our simulation a name. Now the name that we're going to give this simulation is just Mohr Coulomb, because this is the failure criterion of granite, which is the material that we're going to use. And now what we're going to do is just click the green check mark. This is a multi-body part, and as you can see there are 3 separate bodies. We have 2 different bodies for the legs and then 1 body for the top of the bench. And as you can see, I've already created a split line so that we can apply the force to this face right here, because this is going to be where the person, they're a heavy person, they're going to be 400 pounds, this is going to be where they're going to sit down. Now, what we're going to have to do is apply granite to all of these bodies. And at the very top, the fastest way to apply a material to all of the bodies within a simulation is just to right-click and then apply material to all. So that's what we're going to do. We're going to create a granite material and apply that granite material to all of these bodies. The next thing that we're going to do is go down the list, and then what we're going to do is enter in connections. Now remember, a connection defines part-to-part interaction. Now this simulation that I am creating in this video is more of an advanced simulation, and the simulation that I'm creating is a multi-body part simulation. Now the thing about multi-bodied parts is that, well, assemblies too, is that if you have two bodies that share a touching face within simulation, by default, because of the component contact that's already created, SolidWorks will treat those two bodies as if they're glued together. And so in this case, we can skip over connections because all of the contact that's in between the touching faces of the legs and the bottom of the granite bench, those faces are going to be treated as if they're glued together. So we already have connections defined. Then after connections, we're going to skip over to fixtures. Remember, a fixture defines part to ground interaction. And what we're going to do is apply a fixed geometry fixture to the bottom of the legs, and then we're going to move on to loads. Now the load is going to be 400 pounds on this face in the negative Y direction. And then the second load that we're going to apply is going to be from the weight of the granite bench itself. And so we're going to apply that weight. Then what we're going to do is mesh and then run the simulation, and then we're going to take a look at how we can analyze the stresses of this granite bench in order to figure out whether or not the bench is going to be strong enough. I'm going to go ahead and right-click at the top here and apply material to all bodies. And now what we're going to do is we are going to browse our materials. Now the material that we want has not been created. It's a granite material. And so if we're going to create a new material, what we're going to have to do first is copy an existing material. Now what I'm going to do is just copy a random steel material here. It does not matter which one, because we are going to override all of these properties. So I'm just going to go ahead and right click on this one and then select copy. And then what I'm going to do is come into the custom materials folder here. I'm going to right click, I'm going to create a new category. This one will be called brittle. And then I'm going to paste my material in this folder. Right click, paste. Now what I'm going to do is I'm going to rename this, so it's just a slow double click in there. I'm going to rename it to granite. And before I change any of the material properties right here, first thing I'm going to do is come into the appearance, and I'm just going to change this appearance to be a little bit more realistic. So I'm going to browse out of here and come into stone, architectural, granite, and then we're going to apply this granite material. Alright, so this is going to be the appearance of the granite material. So just go ahead and select it, and then come back to properties. And now what we're going to do is we're going to change the material properties of this granite. Now keep in mind, the failure criterion that we're going to use is going to be the Mohr Coulomb stress failure criterion. So go ahead and select that from within the default failure criterion list right here. And once we do that, then what we're going to do is enter in the material properties. Now keep in mind, the material properties that we need for Mohr Coulomb stress are going to be different than if we had our failure criterion as Max von Mises stress. So instead of the elastic modulus, the Poisson's ratio, the mass density, and the yield strength, what we're going to need are the elastic modulus, the Poisson's ratio, the mass density, the tensile strength, and the compressive strength. Because remember, this material fails differently in tension than it does compression. That's why we have to specify both of these here. Alright, now I'm just going to start up at the top and fill in these material properties. Before I do that, I'm just going to change my units to SI units. and then go ahead and enter in the material properties. Now, as I'm doing this, keep in mind these material properties I found on the internet. I don't know how accurate they are. Tensile stress 4.8, compressive stress 130. And then the rest of these material properties we actually don't care about. And now what we're going to do is just click the Apply button and then close. Now what we're going to do is jump down to Fixtures, and we're going to apply the fixtures to the bottom of these faces right here. Just right click, Fixed Geometry. We'll go pretty fast throughout this. And then OK. So all of these faces are going to be fixed. They're not going to be allowed to move. The next step is to apply our loads. Now remember, that's going to be the 400 pounds on this face right here. So we're going to right click on loads. It's going to be a force load. And then what we're going to do is just select this face. We're going to change our units down here from SI to English, because this is pounds, and then we're going to enter in 400 pounds and then click OK. Granite is a heavy material, and so the weight of the bench will contribute significantly to the stress seen in the bench. And so what we're going to want to do is create a second load, which will be a gravity load, so that we'll consider the effects of the weight of the bench. Now the way that we're going to do that is by right-clicking on external loads and then selecting gravity. In this case, I had this face pre-selected. What I can do is I can just right-click on it, clear selection, and then select the top face. Now I want the gravity to be going in the downward direction, or the negative y direction. And if it's pointed in the wrong direction for you, what you can do is click this button, reverse direction, and that will flip the direction of gravity. But in this case we want it down. Alright, and we're just going to leave the rest of the defaults and then press the OK button. Finally, we'll mesh and then run the simulation. Now, I'm not going to go into the mesh at all, but in real life what you'd want to do is converge the mesh, and that would make the stress much more accurate. But in this case, I'm going to leave all of the defaults with the mesh and just click the Run button, and that will automatically mesh and then run the model. And then we're brought to this screen. Now, this is the von Mises stress, and in our particular case, we don't really care too much about the von Mises stress. In fact, the von Mises stress does not mean a whole lot to us. So what we're going to do before we go any further is actually just right-click on stress 1 right here, and then select Delete. And then click Yes to the warning. At this stage, if we were working with a ductile material or any other failure criterion other than the Mohr Coulomb stress, what we would do is create a stress plot, and then we would be able to compare the stress seen in the stress plot to the maximum yield point, or the ultimate tensile strength, or the breaking point, or whatever it happened to be. But because Mohr Coulomb theory treats tension differently than it does compression, there is actually no stress plot that we can look at that would make sense to us. And so what we need to do is actually create a factor of safety plot. And then the factor of safety plot can consider the fact that we are working with the Mohr Coulomb failure criterion. Now, just watch my screen here for a moment. If I right-click on stress, I just want to show you this, and then go into Define Stress Plot. I just want to iterate that there is no plot for the Mohr Coulomb stress, and that's because there is no Mohr Coulomb stress. The Mohr Coulomb stress is a combination of different stresses. Okay, now I'm going to exit out of here. The next thing that I'm going to do is create a factor of safety plot. Now, the factor of safety plot will consider the fact that because this is a material that uses the Mohr Coulomb failure criterion, it will consider tension differently than it does compression. So let's begin that plot right now. I'm going to go ahead and right click on results and then select define factor of safety plot. And now what I'm going to do is go through the steps here. So I'm going to select my failure criterion. Now keep in mind we can leave this as automatic because when we were defining the material of the part, we defined the material of the part to use the Mohr Coulomb stress. In this case, we could use either one of these two options and be all right. But the automatic option right here makes things a little bit more simple for us. So I'm just going to go ahead and select automatic right here and then go ahead and click the next button. The next step is the multiplication factor. I'll just click next again. And now what I'm going to do is I'm going to show the factor of safety plot as a distribution. Okay, and then we'll go ahead and click the OK button. And this is showing the factor of safety on this bench. But as you can see, because of the range of the stress seen in the part, the plot is effectively all red. And so what we're going to want to do is change this plot so that we have a minimum of 1 as a factor of safety and a maximum of about 30. Now the way that I can do that is just by double clicking on this legend right here, and then right here under this define section we're going to define the minimum on the legend to be 1 and the maximum to be we can make it 30, and then we'll click OK. Now that we have the factor of safety plot in place, I want to point out a few things. The first is that we have some locations where we have factor of safety concentrations. Now, a factor of safety concentration isn't necessarily a stress concentration. A factor of safety plot just shows where there are weak spots on a particular design. Now, in this case, we have factor of safety concentrations where the model is experiencing higher amounts of tension. And that makes sense because when we're working with granite, which is a brittle material, it uses the Mohr Coulomb failure criterion, where tension is treated differently than compression. Granite is much more likely to break when you pull it than when you compress it, and that's why we have factor of safety concentrations where we have tension. Now we can effectively treat the factor of safety plot as if it were a stress plot, and what I mean by that is moving forward we'd want to add mesh controls where we have high gradient of factor of safety. So with that said, I hope you enjoy the video. If you'd like to sign up for updates for the blog, please make sure to enter in your name and email on the right hand side. If you have any questions, you can leave them in the comments below and I'll do my best to answer all of them. Thank you and have a great day.